Construction of an electrochemical cell. In order to carry out the above redox reaction indirectly, place zinc rod in 1 m ZnSO4 zinc sulfate solution in the left beaker and copper rod in 1 m CuSO4 solution copper sulfate solution in the right beaker. No reaction takes place in either of the two beakers, and at the interface of the metal and its salt solution in each beaker, where both the reduced and oxidized form of the same species are present. Each beaker constitutes a half cell. It is also called as an electrode or a redox couple. A redox couple may be defined as a combination of the oxidized and reduced forms of the same substance taking part in an oxidation or reduction half reaction. A redox couple is usually represented by separating the oxidized form and the reduced form by a vertical line or a slash, which represents the interface solid oblique solution. For example, in the above experiment, two redox couples are represented as Zn2 plus slash Zn and Cu2 plus slash Cu copper. In both cases, oxidized form is put before the reduced form. Now connect the zinc and the copper rod by a copper wire through a voltmeter or ammeter and an on off switch. Also connect the solution in the two beaker by a salt bridge, which provides electric contact between the two solutions without allowing them to mix with each other. A salt bridge is a U-tube containing solution of an inert electrolyte such as KCl, KNO3, K2SO4, NH4NO3, etc. in agar-agar or gelatin. An electrolyte is one whose ions do not take part in the redox reaction and also do not react with the solution of the electrolytes taken in the two beakers. For example, KCl cannot be used if one of the electrodes is silver electrode containing AgNO3 solution because KCl reacts with AgNO3 solution to form white PPT precipitate of AgCl. When the switch is in the off position, no reaction takes place in either of the beaker and no current flows through the metallic wire. As soon as the switch is in the on position, the voltmeter shows a deflection, thereby indicating the flow of current through the circuit. Let us investigate as to why this current flows. This current is due to the chemical reaction taking place in the two beaker. Left beaker, zinc rod start dissolving in zinc sulfate solution becomes more concentrated. That is, each zinc atom loses 2 electrons to form Zn2 plus ions. The zinc ions then migrate away from the rod into the solution while the electrons move through the wire via voltmeter and ultimately reach the copper rod. The change taking place by may be represented as Zns arrow Zn2 plus 2 electron. Right beaker, copper sulfate solution start getting more diluted and metallic copper start depositing. That is, the electron released by zinc atom in the left beaker in the reaching the copper rod combined with Cu2 plus ions present in the solution to form neutral copper atoms, which in turn get deposited on the copper rod. The change take place may be represented as Cu2 plus 2 electron, then copper arrow copper. The overall reaction taking place in two beaker, Zns plus Zn plus Cu2 plus these are the symbols, S for solid, Aq for aqueous, then arrow Zn2 plus Cu copper. It may be noted here that this is the same reaction which takes place when zinc rod is placed in copper sulfate solution. The only difference is that by this arrangement we have separated the two half reactions, so that is, oxidation of zinc occurs in one beaker and reduction of Cu2 plus ions takes place in another beaker. Further, the transfer of electrons now does not take place directly from Zn to Cu2 plus but through the metallic wire connecting the two rods as shown by the deflection in the voltmeter, which shows the flow of current. The cell based on the above reaction is commonly called a Daniell cell. A popular form of this cell is shown in the figure. Here, salt bridge is replaced by the porous pot through which SO4 to negative ions migrate from CuSO4 solution to the ZnSO4 solution. This is a popular form of Daniell cell. SO4 to negative, here it is, zinc rod, this is zinc rod, ZnSO4 solution inside it, and SO4 to negative, here porous part, this is the sub bridge, and the copper vessel, this is copper vessel. Here it is connected by voltmeter, and this was the electrons. Salt bridge and its function we'll discuss in the next video. Thank you.